Welcome to today's Explainer. Today, we're diving into something that feels practically like magic, but is actually completely logical. We are going to build a smart, fully automated car parking system using a programmable logic controller, or PLC. Think of a PLC as the brain of a system, the sensors as its eyes, and the actuators as its hands. We'll be using GXWorks 2 software to design our ladder logic today, and you'll see exactly how these three components work together perfectly to run the whole show. Okay, let's take a quick look at our agenda for today. 1. Smart parking automation. 2. Sensors and hardware inputs. 3. Actuators and outputs. 4. Writing the ladder logic. 5. Simulating the parking system. And finally, 6. Industrial automation importance. Let's get right into it.
Section 1. Smart parking automation. Solving real-world problems. Imagine trying to run a busy parking lot entirely automatically, with absolutely zero human intervention. Well, to solve this real-world problem, our system relies on three foundational pillars. First up is the PLC, our system's brain, which processes all the logic. Second, we have our sensors, acting as the system's eyes to see the physical world. And third, the actuators, which are the hands that execute the commands. By combining these three, we can seamlessly manage arriving cars, track available spaces, and operate the entry gates. Section 2. Sensors and hardware inputs. The eyes. So what exactly are the eyes of our system? We're using proximity and IR sensors. Here's how they work. An IR sensor sends out an invisible beam of infrared light. When a car pulls up, that light bounces off the car and right back into the receiver, instantly detecting the vehicle without ever physically touching it. In our setup, we place a proximity sensor at the main entry gate to detect incoming cars, and we place individual IR sensors at every single parking spot so we can constantly track whether a spot is empty or occupied. Now, to keep our logic really clean and easy to follow for this tutorial, we're setting a strict mathematical baseline of exactly 5 parking spots. Honestly, whether you're managing 5 cars or 5,000 cars, the core principles of PLC ladder logic remain exactly the same. But by capping it at a 5-car capacity today, we can build a really tight, easily understandable program. Section 3. Actuators and outputs. The hands. All right, so the brain has made a decision based on what the eyes saw. Now it's time for action. These are our outputs. First, we have the gate barrier motor, which physically lifts the arm so a car can enter. Next are our visual indicators, a friendly green or yellow light when there's space available, and a bright red light when the lot is completely full. And for safety, we've also wired in a warning buzzer that sounds for exactly 5 seconds whenever the gate opens, just to alert any pedestrians nearby. Section 4. Writing the ladder logic, the brain. Before we dive into the actual code, ask yourself this. How does the system know the lot is full? I mean, it doesn't have a human brain to just look around and count. This is where the magic happens. Using Mitsubishi's GXWorks 2 software, we are going to translate those physical hardware states into strict mathematical conditions so the system can make smart decisions completely on its own. To write logic in GXWorks 2, you have to understand the absolute foundation of it all, normally open or NO and normally closed or NC contacts. Think of an NO contact like a broken bridge. Electricity won't flow until the sensor is activated and the bridge connects. We use this for our gate sensor. On the flip side, an NC contact is a connected bridge. Electricity flows freely until a car parks and breaks the circuit. For our 5-car lot, we can actually wire the 5 parking spot sensors in series using NC contacts to create a perfect set of logical conditions. Let's walk through the exact logical sequence our code will execute. Step 1. The proximity sensor at the gate detects a car, which closes that NO contact. Step 2. The PLC reads this signal and instantly updates its internal parking counter. Step 3. Since the lot isn't full yet, the PLC fires a signal to activate the gate barrier motor. And Step 4. The moment that counter hits exactly 5, a new rule triggers. The red full light clicks on and power to the motor is cut so the gate won't open for the next car. But we aren't just limited to basic contacts. In GXWorks 2, we can use advanced counters and math blocks. We set up separate up-down counters for both the entrance and the exit gates. By using a simple math subtraction block, literally just subtracting the exit count from the entrance count, the PLC knows exactly how many cars are currently inside. As soon as that value hits 5, a math comparator triggers, the red full light comes on, and the green available light switches off. Section 5. Simulating the parking system. Testing the code.
Now, in the real world, you would never, ever deploy code to live industrial hardware without testing it first. This is where simulation and animation are absolute game changers. By using a software simulator, you can watch a real-time virtual animation of your system. When you force close a sensor input contact in your GXWorks 2 ladder logic, you instantly see the output trigger and the virtual 3D gate swing open on your screen. It beautifully bridges the gap between your abstract code and the physical, real-world outputs.
Honestly, the best part of running a simulation is getting to push your code to its limits. Imagine sending 5 virtual cars through. You watch the counter hit 5, and boom, the red light comes on. Then a 6th car pulls up to the gate. The proximity sensor turns true, but because our math block has logically locked the system, the actuator output stays totally false. The gate safely stays down. Your logic is flawlessly preventing the system from overfilling. Section 6. Industrial Automation Importance. Why this matters. You might be wondering, why is building a simple 5-car parking simulator so important for your career? Well, it's because these exact same ladder logic principles are what drive Industry 4.0 and the biggest automation companies on the planet. Whether you're using Mitsubishi Electric, like we did today with GXWorks 2, or Siemens, Allen Bradley, ABB, Schneider Electric, or Delta, the core concepts of normally open, normally closed, and math comparators are completely universal across all these major global brands.
As one of our sources perfectly summarized, PLCs are critical in industrial automation, and choosing the right one is essential. The exact same fundamental logic you just learned to control a basic parking garage gate is the exact same logic used to run multi-million-dollar robotic assembly lines, massive water treatment facilities, and complex airport baggage handling systems. It's the absolute backbone of modern industry.
So there you have it. You now have a solid grasp on the brain, the eyes, and the hands of modern automation. You've seen how to write ladder logic in GXWorks 2, how to safely connect all your inputs and outputs, and how to validate your code using real-time animation. So I'll leave you with this. Armed with these universal PLC principles, what physical process will you automate next? The possibilities are quite literally endless. Thanks so much for joining me for this explainer. Keep learning, keep building, and I'll see you next time.